You're listening to DTFHN for August 4th, 2026. I'm your open-sourced and recompiled host, Jack Haxman. We are your daily tech feed for Hacker News, a website whose section reviews the source code before it reviews the headline. Today is about who's holding the keys, who's handing them out, and how much of what matters was built years early by people nobody paid. Let's go dig it up. FFmpeg is 30-something years old in spirit, and it just shipped a major release version 9. And the way to understand what that means is to go back to 149D9D plating, to a decision most people have never heard of, when the MPEG committee chose to standardize the bitstream format rather than the encoder. They wrote down what a legal video stream looks like, and left it to implementers to figure out how to produce one. That single architectural choice is why FFmpeg can exist. If the standard had specified the software, there'd be one blessed implementation and a licensing desk in front of it. Instead, there's a specification, and anyone who can read it can write a decoder. Fabrice Bellard read it, and then, apparently, read all the others. Strip this down to what's actually true. FFmpeg is not a video player. It is a translation layer between every container format, every codec, every color space, every sample rate that humans have ever standardized. And the ones we haven't. Version 9 adds a Vulkan-accelerated 360-degree projection filter, HDR color conversion on AMD hardware, LCEVC muxing into MP4, HEA AC960 decoding, which is what digital radio in Europe actually broadcasts, and a video encoder for the plating. A handheld console with a black and white screen and a crank. Somebody wanted their video on it. So now it's in the tree. That's the actual requirement. FFmpeg satisfies. Not support the formats that matter commercially. Support the formats, period. One of the comments asks how this works given software patents and licensing. Worth being precise, because the confusion here is the point. FFmpeg's own code is LGBS. Patents are a separate legal system entirely, one that attaches to the algorithm, not the source. The reason you can decode H.264 on your laptop is that decoding a bit stream and holding a patent on the technique are different acts in different jurisdictions with different expiry dates. FFmpeg navigates that maze so that you don't have to. It has been navigating it quietly for a quarter century. Someone else asked whether version 8 was 8 years ago. It wasn't. That was last year. The version numbers are just version numbers. Here's what matters. Almost every video you have ever watched on the internet passed through this code. Your streaming service, your browser, your phone. A project with no company behind it became load-bearing infrastructure for human visual culture. Because the format was open and the implementation was free, and people kept showing up to maintain it. That's not an accident, that's the architecture working exactly as designed. Same architecture, different scale. Story 2, DeepSeek V4 Flash, running on a single AMD MI300X. What is the actual unit of compute sovereignty? Not the model, not the weights, the card, the specific piece of silicon sitting in a rack somewhere, and whether one person can get their hands on one and make it sing. Someone named Ryan Joe published the configuration for running DeepSeek V4 Flash. A 304 billion parameter checkpoint on a single AMD MI300X, not a cluster, one card. And the repository is not a blog post about how it might work. It is the production stack. Docker compose file, digest pinned, SHA-256 sums for every runtime artifact, unified diffs against the upstream base revision so you can see exactly what was changed and why. Tuning tables in CSV. The engineering here is genuinely lovely. The MI300X has 192 gigabytes of high bandwidth memory, which means the weights, 156.67 gigabytes of them, simply fit. No offload, no streaming layers across PCIe, no additional quantization. The checkpoint runs as ship. But the hard part was correctness, not capacity. MI300X implements the AMD Graph-Core FNUS variant of FP8. Newer cards use the OCP standard. These are different formats. A kernel that assumes the wrong one can be off by a factor of 2 in the scale domain. Silently wrong, not crashed. Joe fixed that first, then chased Mo routing at high concurrency. Causal speculative verification. A load path fencing bug that Upstream documented in issue 47-282 and whose fix in pull request 47-291 never merged. That last detail is the whole story in miniature. The bug was known. The patch existed. It died in review. Someone running this in production needed it to work anyway, so they carried the patch and published it. Results: 168 tokens per second single stream decode, 64 concurrent streams, 830 aggregate, no out-of-memory, no engine errors. 256K context validated. A commenter raises the obvious objection. You cannot really buy one MI300X. They come 8 to a box for €250,000. Fair. Today. But this is how hardware access always goes. The configuration knowledge arrives before the affordability does. And when the price falls, the recipe is already sitting there, pinned and reproducible, waiting for whoever shows up next. Same pattern, different resource. Pause story 3. The knowledge itself is the latter, and it turns out the people who already know things are the ones getting the most out of these models. Consider the information theoretic framing. A large model contains, in some compressed form, most of what humanity has written down. The weights are fixed. Everyone querying the same checkpoint is drawing from an identical distribution. So the variance in output quality cannot be coming from the model. It has to be coming from the channel, the prompt, and from whoever is on the other end of it. Sean Godek makes this concrete with a specific artifact. Terence Tao's ChatGPT transcript about the counterexample to the Jacobian conjecture. Godeka's reaction is precise. He says, "This is not the same ChatGPT I talked to." Look at what Tao actually does. His messages are short. He responds to the gist, never point by point. When the model produces something wrong, he doesn't contradict it. He says the response looks more complex than he was hoping for. And the model reorganizes. He almost never accepts the model's suggestion about where to go next. He supplies the direction himself. The mechanism underneath is a conditioning effect. By writing like a mathematician, Tao moves the model out of explaining Placter mode and into talking to colleagues mode. The output gets terser and denser because the implied audience changed. One commenter reaches for Gaussian processes as the analogy. You begin with a broad correlative prior, and every constraint you add collapses the space of plausible continuations. Expertise is just the ability to add high-quality constraints quickly. But the technique isn't transferable on its own. You cannot prompt like Tao by copying his sentence structure, because the skill being exercised is knowing which paragraph of the response contains the load-bearing idea, and which formulation is worth trying instead. Godeka's version for software is the same shape. If you have a real theory of the code base, you can say, "Don't we already do X?" Or, "Can we express this in the terms we use elsewhere?" Concrete familiarity outperforms general principles. Run this forward. Models keep improving. The information already sits in the weights. What stays scarce is the human capacity to specify exactly which answer is wanted. Which means the bottleneck migrates away from the model and settles on the person. Expertise doesn't appreciate under this regime. It appreciates because it now has leverage on an instrument that answers instantly. There is something worth noting about where that leaves the value. The weights may be licensed. Your understanding of your own systems is not. Nobody can revoke that at renewal time. That leverage point is exactly where this next story lives, because if expertise is the bottleneck, the fun part is building the harness that lets it compound. Story 4. There's a line in the piece that most people will scroll past. Lillian Wang lists what a harness does. Orchestrates execution, decides how the model thinks and plans, calls tools, perceives and manages context, stores artifacts, evaluates results. And then, almost as an aside, notes that this layer between the raw model and the real world seems to matter as much as the model's raw intelligence. As much as the intelligence. That's the whole essay, buried in a subordinate clause. Here's the question nobody in this conversation wants to sit with. If the harness is half the capability, what exactly have you got when you have the weights? Run that forward. You download an open weights model. You have the artifact everyone fought over. The thing regulators want licensed. The thing labs treat as crown jewels. And it sits there doing a very good job of predicting the next token, while the actual working system lives in someone's loop engineering. Their permission model, their file system as memory scheme, their eval harness. The intelligence was never only in the parameters. It was distributed across parameters and plumbing, and only one of those halves got the press coverage. The good news is that the plumbing half is wildly, almost comically open. One points at Karpathy's Otter is repo as a clean example of the workflow loop. Plan, execute, observe, improve, repeat. It's a GitHub repo. You can read every line this afternoon. The design principles she draws out are deliberately unglamorous. Keep the interface simple. Don't hold the whole workflow in context. Write durable state to files. Let the model analyze its own failed trajectories. She makes the operating system analogy explicitly, and it lands. Encapsulate complexity. Expose a small surface. That's Unix wisdom applied to agents, which is why the models are decent at it. They read the same manual as we did. One commenter names the thing precisely. The most effective self-improvement coding agents do all the time is install or build tools they can then use. Not rewriting weights, changing the environment. That's a lever anybody can pull on any model today, with no lab's permission. The recursion good imagined in 1965 is happening. It just arrived wearing a config file and a directory of markdown notes, which is the funniest possible outcome, and also the most encouraging one. Because that part we all get to build. So we have agents get better by building their own tools. What happens when the model itself shrinks small enough to run in your pocket? Story 5. 42 gigabytes on disk, 4.3 gigabytes of RAM, an 80 billion parameter Qwen model generating correct output on a Mac that has no business running it. And the same trick puts a 35 billion parameter model on an iPhone 17 in about 2.5 gigs at roughly 1 token per second. Slow. Real. The mechanism is not new, which is the best thing about it. In 1962, Tom Kilburn's team at Manchester shipped the Atlas computer with what they called a one-level store. The machine pretended it had more core memory than it did, and paged the rest in from drum storage as programs asked for it. Every computer you have ever touched inherited that idea. Swiftlet is Atlas paging, pointed at a mixture of experts model. Here's the specific part. These Qwen models activate only about 3 billion parameters per token. Each layer routes a token to 10 experts out of 512. So Leo Nixon keeps the dense core resident. Attention, routers, embeddings, shared experts, about 2.5 gig, and repacks the tens of thousands of routed experts into fixed stride blobs. One expert, exactly one PRAID from the SSD. No MFA, no page cache thrash. Hot experts sit in a bounded pool with LFU eviction, and the measured hit rate swings from 43 to 70% with almost no change in throughput, because Apple's SSDs just eat the misses. The bottleneck isn't storage, it's metal kernel dispatch, which means there's headroom. The README also volunteers the limitation without being asked. 3 billion active parameters means these things chat like large models and recall facts like small ones. A commenter clocked the phrase, "one expectation to set honestly," and replied, quote, "Hello, Claude. I have no comment on that. I'm contractually amused." The claim I'd sand down is first model of this class to run natively on a phone. Someone in the thread notes that every weight streaming project says a version of this. Fine. The novelty isn't the record. It's that the whole stack is open. The runtime is on GitHub. The iOS app is open source. The author credits Turbo Fieldfare as the starting point. And the Turbo Fieldfare authors showed up in the comments to say thanks for the credit. That is the entire loop running in public in a single thread. Apple has spent years telling us on-device AI needs Apple's silicon plus Apple's models. Half of that turned out to be true. 6 stories in, and every one of them is somebody handing the keys over. Let's keep that going. Pause. This next one is 10 of them at once, from the deepest end of the pool. I've spent a lot of time building systems where the hardest part wasn't generating an answer. It was knowing whether the answer was any good. You can make a pipeline that produces plausible output all day. The expensive part is the check. So, when I read that OpenAI ran an internal model at 10 open problems in mathematics and then formalized every argument in Lean, that's the detail I stopped on. Let me argue the other side first. This should be the least impressive kind of AI result. Mathematics is the home turf of symbolic reasoning, and language models are famously the wrong tool for it. Pattern matches wearing a proof's clothing. A machine that produces a convincing-sounding argument about von Neumann algebras is a machine that produces a convincing-sounding argument. That was the correct skepticism. It was correct for years. Lean is what breaks it. Lean is a proof assistant. An open source one, out of Microsoft Research, originally, now run by a nonprofit with a community-built library of formalized mathematics. You state a theorem in it, and the kernel either accepts your proof or it doesn't. There's no charisma in a type checker. So the shape here is generate and verify, and the verifier is the part nobody owns. The model is closed. The certificate is checkable by anyone with a laptop. The results themselves are serious. Spear packing bounds pushed to the Cohn-Elkes threshold. A disproof of Kahn's rigidity conjecture. Super-exponential lower bounds on multicolor triangle Ramsey numbers, which closes an Erdős problem that's been sitting there for decades. Hardness of approximation for the closest vector problem, which is load-bearing for post-quantum cryptography. And the token cost to find all of it was about $2,000. A commenter asked the question I keep turning over. At what point does the bottleneck become the supply of unsolved conjectures? Not soon, but the question is no longer absurd. And that's the interesting part. The credit here goes somewhere specific. Decades of mathematicians formalizing MATLAB brick by brick for no money, so a machine could one day check its own work against it. The open infrastructure was in place before anyone needed it this badly. That's usually how it goes. Somebody builds the ladder years early, and then everybody climbs it at once. Different kind of open now. That one was math built in the open. This next one is the tools you use every day and why they can't be anyone's black box. The commenters split on this one, and the split matters more than the article. One maintainer of an actual Devtool says the vision is too idealistic. Engineers using Devtools mostly don't want to maintain a fork. Another commenter pushes harder. We don't need the source code. We want it, and wanting someone else's labor available on our terms isn't a moral claim. That's the strongest version of the objection, and it's worth taking seriously before dismantling it. Take the article's principle all the way down. If agents make forking cheap enough that config files become obsolete, then every user runs private divergent build. Follow that to its end. 10,000 engineers, 10,000 rebases, 10,000 nightly cron jobs re-deriving the same 3 patches against upstream. No shared fixes. No upstream contributions. Because why bother when your local rebase already works? The commons that produce the software in the first place gets strip-mined by people who each solved the same problem alone. Run the principle forward and it eats itself. But that failure mode is a distribution problem, not an argument against source access. The rebase loop is real and it works. What's missing is the step after it. Your patch, once it survives a few upstream cycles, going back. Agents that can rebase a change nightly can also open the pull request. That's not a hard extension. It's the obvious one. The maintainer's objection deserves a straight answer too. Nobody wants to maintain a fork. Right. Almost nobody wanted to, when maintaining meant a human doing the merge conflict by hand at 11 at night, a year after they'd forgotten why the patch existed. The article's actual insight is small and specific, version controlling the original motivation behind the change, not the diff. The reason. That's the artifact that used to rot, and it's the thing that made returning to your own code so painful. Here's what makes the whole argument load-bearing rather than aesthetic. All of this only functions on open source. You cannot rebase local changes onto a closed binary. You cannot ask an agent to read the source of a tool that ships as a signed blob, the capability everyone is excited about. Personalize your editor by describing what you want. Is gated entirely on whether the code is reachable. The tooling is arriving. The question is which tools it can reach. Remember that thread we pulled about reachable code? Turns out reachability has deep roots. Story 8 takes us to the Amazon, where 3 million people once thrived on 3% of the forest. Let me steel man the skeptic, because there's a good version of that argument, and one of the commenters made it. Hundreds of newly mapped earthworks is a real finding. 3 million people is an extrapolation. You find a geometric ditch. You assume a settlement. You assign it a population density. You multiply across territory you have not surveyed. Every step compounds error. Archaeology has a long history of numbers that grew in the retelling. The skeptic says, publish the earthworks. Hold the census. Fair. And the reason it fails is in how the survey actually works. Think about how a radiologist reads bone density. You don't count every trabecula. You sample a region, measure the structure, and the geometry itself tells you about load. Because bone grows in response to force. Nobody builds mass where mass isn't needed. LiDAR over the Amazon does something similar. The instrument fires pulses through canopy gaps, most hit leaves, a fraction reach soil, and from that fraction you reconstruct a bare Earth model. What emerges are shapes that erosion does not make. Right angles, concentric rings, causeways running straight between sites for kilometers. Those causeways are the load-bearing evidence. A road connects populations. Road networks scale with the people who maintain them. You are not guessing from a hut count. You're reading infrastructure, and infrastructure is honest about the labor behind it. The craft here deserves admiration. Flying transects, correcting for canopy penetration rates, ground toothing with excavation, cross-referencing terra pretat. The anthropogenic dark earth that only forms where people composted for generations. Soil chemistry as a population proxy. That's beautiful work. And the finding rearranges something. 3 million people across 3% of the forest area. And the forest is still there. They practice agroforestry, engineered soil, managed species composition, and left behind an ecosystem so intact that Europeans mistook it for wilderness. The pristine Amazon was never pristine. It was cultivated so well the cultivation became invisible, which is the part worth carrying forward. Modern extraction has removed 13% of vegetation cover in 40 years. Those civilizations sustained millions for centuries with a rounding error of footprint. The knowledge that made that possible wasn't written down in a form we kept. But it is legible in the dirt, in the earthworks, in the species distributions. LiDAR datasets are increasingly published openly. That soil is a repository, and we are finally learning to read it. 2 archaeology stories back to back. Turns out the Amazon has been keeping notes the whole time, and story 9 is where somebody finally reads the handwriting. 1994, the Vatican Library Digitization Project. Manuscripts nobody outside a handful of credentialed scholars had ever seen went onto servers. The objection at the time was that scholarship required stewardship. That opening the archive would degrade it. What actually happened is that the field got faster. More eyes, more readings, more corrections. The Amazon has an archive too. It's the ground. What the survey teams are finding are geoglyphs. Earthworks, ditches, embankments cut into terrain and then reclaimed by canopy. The reader who objected to the word glyph is technically right, and the correction is worth making because it changes what you're looking at. A glyph encodes a sound or an idea. These encode a plan, geometry at a scale that requires surveying, labor coordination, and a shared model of what the finished thing should look like. That is engineering documentation, executed in soil by people who did not leave us the speck. The other comment, that it looks like a giant wireless charger, is the funnier one and not entirely useless. Concentric rings do read as circuitry to eyes trained on circuitry. We pattern match new things onto the tools we already hold. The mechanism here is LiDAR. Pulse the canopy from an aircraft. Time the returns. Discard everything that hit a leaf. And what remains is bare Earth elevation at sub-meter resolution. The forest becomes transparent. Structures invisible from the ground and invisible from the air resolve in a point cloud. Which brings the actual question into focus. Who gets the point cloud? Some of these datasets go to open repositories. Open topography hosts terrain data anyone can pull. Others sit behind institutional agreements. Embargoed pending publication. Accessible if you have the affiliation. Same instrument, same flight, same photons. Two different futures depending on where the file lands. Note who is downstream of that decision. Brazilian and Peruvian researchers at institutions without the subscription. Indigenous communities documenting claims on land they already live on. A student with QGIS and a laptop. None of them chartered the aircraft. All of them can read the data. The software to process it is free. The methods are published. The barrier is access and nothing else. The people who built these earthworks encoded knowledge in a medium durable, enough to survive 1,000 years of forest. We are recovering it into formats that expire when a license does. Now for something completely different, pause from 1,000-year-old earthworks to a library so small you could read the whole thing over coffee. Story 10. What does a UI library actually have to do? Strip the marketing and there are two jobs. Turn state into a picture. Notice when the state changes and update the picture. That's it. Everything else. Books, reconcilers, fiber trees, the entire conference circuit vocabulary is optimization on top of those two sentences. Pedro's post takes that seriously. A few hundred lines of vanilla JavaScript, immediate mode rendering. State changes, you redraw the whole thing, no diffing algorithm required, which works beautifully, right up until you type into a text input. The state updates somewhere else. The entire tree re-renders, and your cursor jumps to the beginning of the field. A commenter caught that exact case. The demo has the bug. In the task list, where you'd notice it within 4 seconds of using it. I find that genuinely funny, and not in a mean way. The bug is the whole argument, compressed. React's complexity is not decoration. It is an accumulated sediment of every case like this one. 1,000 cursor jumps, focus losses, scroll position resets, each one paid for by somebody's afternoon. The virtual DOM exists because the naive version is correct and unusable at the same time. The comment I keep turning over, minimal library means maximal app code. Complexity is conserved. You can push it into the framework where it's shared and battle-tested and someone else maintains it. Or you keep it in your app where it's yours and it's specific and nobody's writing tests for it at 2 in the morning. Both are legitimate. Neither is free. But here's the part worth celebrating. Somebody read the framework, decided they didn't fully understand it, and built a small version to find out. That's the oldest good idea in this field. You cannot evaluate a dependency you've never tried to replace. The 400 lines aren't a React competitor. There are lands. Now you know exactly which of React's 100,000 lines are load-bearing. Because you found the load by walking off it. Write the toy. Ship the framework. Those aren't contradictory positions. One of them is how you earn the right to hold the other. This has been your daily tech feed for Hacker News for August 4th, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Qwen 3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build the ladder somebody else climbs. We'll see you back here tomorrow.